Okay, good afternoon. Good afternoon. If you are able to see the screen, you're also able to hear, then just let me know. Indicate something in the chat. Let me know if we're all good. All right, so we're going to get going immediately. Now, for this session, we want to carry out the session in an interactive manner. So the aim is to have persons be able to participate as we go through each question. So you will see on the screen I have the questions open, as well as an interface window where persons can select an option based on each question. So if you are able to check in the description, if you see in the description, you will see the link that will allow you to participate in this session. So if you click on that link, it will take you to the page in which you can input your answer, and we will take a moment to actually discuss the questions in detail. So again, persons who are able to, if you can just indicate in the chat that you're hearing and you're seeing the screen so that I know that we're all good and we can just begin. All right, can someone just indicate a thumbs up in the chat to let me know that we're all good? The audio is clear and you can, okay, perfect. All right, good. Okay, wonderful. All right, so as I was saying, so we have the question screen open and we have the responses screen. So as we go through, I would want persons to give their feedback on the questions, whether the option is A, B, or C, and we're going to spend some time discussing that. So we're going to start immediately with our first question. So the first question says, which of the following is the unit for frequency of a vibration? So if you check in the description, you'll see a link. If you click that link, it will take you to another environment where you can select your option, whether A, B, C, or D, based on what the list that we have right here, which is A for M, B for S, C for S to the minus 1, and D, MS to the minus 1. So you can vote which you think is the answer, and then we're going to discuss and finalize what is the option. So let's see if we can do that. So for persons who are just joining, if you check in the description, there's a link that will take you to the environment where you can select an option. So we're on question 1 now. Which of the following is the unit for frequency of a vibration? And for persons who are checking the link, you can let me know if there are any challenges so that we can fix any issues from the get-go, so that as we go into the questions, it's a lot smoother for everyone. So again, once you click that link, it will take you to the area where you can select your option, whether it's A, B, C, or D. Can someone confirm if they're seeing the link to choose an option? All right, let me know, please, if you can. All right, so you can select your option, whether it's A, B, C, or D. Then we will discuss. I just need to see at least one person selecting an option so I know that it's working on your end. All right, so once you click the link, it should take you to the Mentimeet page, and you can select your option. Okay. All right, so I see persons selecting C and D. All right. Okay. Not sure why it's not showing on the active screen at the moment. All right, but I'm seeing persons on my end. I'm seeing persons selecting options C and D. So let's just discuss right here. So it says, which of the following is the unit for the frequency of a vibration? So we can recall that frequency is essentially the number of, just right here, frequency is the number of oscillations or cycles completed in 1 second. So frequency really defines the number of cycles per second. Right? So it's the number of oscillations that are completed in a certain time, right? And we use the second as the SI unit for time. So therefore, what we're going to see now is that when we talk about the frequency, we're familiar with the frequency being measured in hertz, right? And 1 hertz represents 1 cycle per second. So 1 hertz is the same thing as 1 cycle per second. So therefore, what we see now is that the unit for frequency can be represented as the per second, or s to the minus 1. So we're going to go with C for that one, right? So from the options, I see 2 persons selected C, 1 person selected B, and 1 person selected D. So if you're one who selected C, that's good. I'm not sure why that screen is not showing up. Let me see if I can fix it in any way. Am I on the right screen here? All right, hold on a second. One second, let me see if I can fix something. Yes, I'm on the right screen. So I'm not sure why it's not displaying on your end. Anyways, so we continue. All right, so our next question, question 2, and let me just go to the next slide so persons can answer for question 2. So question 2 now, it says, which of the following pairs consist of fundamental quantities? So we have option 1, which says, all right, some person in the code not working. All right, let's see if I can see what's happening with that. All right, so code seems to be working, so not sure what's really happening for you in particular, but let's continue. So our question says, which of the following pairs consist of fundamental quantities? So we have mass and weight for option 1, we have mass and length for option 2, and we have time and current for option 3. Now, we should remember that fundamental quantities, those are the very basic physical quantities, and the complete list includes mass length, time, temperature, and electric current. Those are our 5 base quantities, or our 5 fundamental quantities that we are exposed to at this level. So if we go through our options, we see that we have mass right here, we have length, we have time, and we have current. So all these are fundamental quantities. Weight, in fact, is a derived quantity, so we will eliminate that one. So therefore, option 1 is not true. So we're going to see then that our option there is going to be option D. Right? So again, persons can vote in that area. All right, so we continue. Question 3 says that the volume of a rectangular block of material which has dimension 400 centimeter by 400 centimeter by 125 centimeter is. So we have the dimension being given right here, and we want to find the volume of this rectangular block. Now we can remember that the volume of a rectangular object is simply its length multiplied by its width multiplied by its height, right? Or some person might say length times breadth times height. So in this case, now we're given the dimensions in centimeter, as what we see right here, and they want us to determine the volume in cubic meter. So 2 ways we can do this. We can actually go ahead and actually calculate the value with our values in centimeter, but then we would have to convert. Or we can simply convert these to meter and then do our calculation. So to convert to meter, we simply divide by 100. So we're going to divide each of these by 100. So we're going to get 400 divided by 100 is just 4 times 4. And again, these will be meter. This is 125. We divide by 100, so we're going to get 1.25. And we can take a calculator and just multiply these. And once we multiply these, we will get 4 times 4 is 16. 1.25 times 16 would give us 20. So our answer would be 20 cubic meter. So that's B. Right? I did not go forward. Right? All right, so I have to remember to skip to the next question so persons can select their option. All right, so question 4. Let's go forward. All right, so question 4 now says that the instrument most suitable for measuring the external diameter of a test tube is. So we want to determine which instrument can be used to measure the external diameter of a test tube. We have the micrometer screw gauge, we have the vernier caliper, we have the meter rule, and we have our set square. All right, so again, you can choose your option for question 4, whether A, B, C, or D, and then we're going to discuss. All right, so let's see our options again. So we have the micrometer screw gauge, we have the vernier caliper, meter rule, and we have the set square. So the most suitable instrument right that we can use to measure the external diameter of the test tube would be our vernier caliper. So we're going to go with B for that, which is our vernier caliper. So where someone selected micrometer, the micrometer will not be or may not be suitable for the test tube since the micrometer it has a limited range and the external diameter of the test tube might be greater than the range of that micrometer. So the best answer would be our vernier caliper. So we're going to go with B for that one. Some of those things, I guess, for question 3, right? So notice that we have the unit in centimeter right here, but our answer is given in cubic meter. So if we multiply these, we would get, in fact, the 20 million that you are suggesting right here. But however, that's going to be in centimeters cubed, right? And we would have to divide well, we would have to convert from centimeters cubed to meters cubed by dividing by 100 cubed, which is a million, which would get us back to 20. Hence why our answer would be B for that one. So question 4, we go with vernier caliper, right? So let's go to question 5 now. So question 5 says that the density of a substance P is 0.8 times the density of water. Which of the following statements are true? Option 1 says the relative density of P is 0.8 kilogram per cubic meter. Option 2 says that P will float in water. And option 3 says that, well, it should be 3. Option 3 says if a given volume of water of mass 5 kilogram, an equal volume, if a given volume of water is of mass 5 kilogram, an equal volume of P will have a mass of 4 kilograms. So let's go through and see what we see. And before we do that, I'm going to give you some time to select the options for question 5, and then we will discuss. Oh, let me scroll on a bit so you can see the full options. All right, so person selecting D. All right, so I'm seeing person selecting D for this one. All right, so let's go through. So again, it says that the density of the substance is 0.85 times the density of water. Right, which of the following will be true? So option 1 says that the relative density of P is 0.8 kilogram per cubic meter. Now we should remember that the relative density, it is expressed as a number only without a unit, because in fact relative density is dimensionless, right? So therefore option 1 would be false, right? So we're going to ignore option 1 because again we should not have a unit for relative density. Right, option 2 says that P will float in water. So since the density is 0.8 times the density of water, what that means is that the density of the substance is in fact less than the density of water, right? So as a result of that, the object will in fact be able to float in water. So this is true, right? Option 3 now says if a given volume of water is of mass 5 kilogram, an equal volume of P will have a mass of 4 kilogram. So this statement is also true, right? So options then now would just be 2 and 3 only. And in fact, if you look at our options right here, since we would have eliminated option 1, then everything goes except C. So our correct answer then now would be C right here. Right, so that's question 5. Right, so in fact, no one was able to select C for that one. So let's go to question 6. All right, so question 6 says, which of the following is dimensionless? Now, we just talked about it a while ago. We said relative density was dimensionless. So again, we're going to simply go with that. Probably I should have given you time to, I guess, weigh in on that, but we essentially just spoke about it earlier. So our answer for this one would be relative density, which is B. All right, so that's question 6. Let's go speedily. All right, so question 6. Question 7 now. So question 7 says a uniform rod XY of weight 40 newtons is held in equilibrium horizontally as shown in the diagram above. Which of the following is true? All right, so let me zoom this out a bit. All right, so these are our options for question 7. All right, so let me just give you some time to select your answer for question 7. All right, so seeing option B being selected, also D. All right, so let's see if we can go through this one. So it says we have a uniform rod XY. Its weight is 40 newtons. Now, since it is uniform, the weight will act at the geometric center, right? Which we can refer to as the center of gravity. All right, so this is the center of gravity right here. So the weight will be acting down at the center of gravity. Now, we have this 10 Newton force being applied closer to T1 at point X, right? So now we can just consider that, okay, since the weight is acting at the center, T2 and T1 will equally share the force due to the weight because it is at the center. Now this 10 Newton force is closer to T1. So T1 therefore would have to bear more of that force. So what we're going to see now is that T1 must apply a greater upward force than T2. So our correct answer then now, we're going to go with is D, which says that T1 is greater than T2. So we'll go with B for that one. So that's question 7. Question 8 now. Let me go forward. All right, so question 8 now says, in which of the following is the quantity correctly paired with its unit? So we have our quantity, we have the unit. So we have mass, Newton, corresponding to Newton. We have moment of force, corresponding to Newton meter. We have energy, corresponding to Newton meter. And we have work done corresponding to Newton per meter. So let me give you a few seconds to put your answers in. And for persons who are in the chat and maybe not able to access the link, you can participate by sharing your answers in the comment area so we can keep the comment section active. So we're on to question 8. All right, so I'm seeing a battle between B and C. All right, so it's dead heat between B and C. So we're going to have to settle this shortly. All right, so let's look at this. So we know, okay, mass is measured in kilograms, so this is definitely out. SI for mass is a kilogram. Moment of force, right? So we can recall that the moment of a force, T, is equal to the force multiplied by the perpendicular distance. So as a result of that, we're going to get force in Newton being multiplied by the perpendicular distance in meter, right? So we're going to get Newton meter, right? Not Newton per meter. So this one is not so. C now says energy, Newton meter. Now we can recall that energy is essentially the ability to do work. And if we, for instance, look at, let's say we look at gravitational potential energy, we can show that gravitational potential energy is simply equal to the mass multiplied by the gravitational field strength multiplied by the height above the ground. Mass is measured in kilogram. Gravitational field strength is in Newton per kilogram, and the height is measured in meter. So if we pay close attention, we can observe that this kilogram cancels with this one, leaving us with simply Newton meter. So energy, in fact, can be measured in Newton meter. And in fact, 1 joule is the same thing as 1 Newton meter. So therefore, we're going to see that C is true. So we can settle on our answer being C. All right, so we'll go for C for number 8. Now, work done and energy would have the same unit. So this one definitely would be false. All right, so that's question 8. Now, question 9 now. says, in relation to the diagrams below, which of the following statements is/are correct? So we have these three figures right here, body A, body B, and body C. It sounds a little bit like Newton's third law, body A, body B. But we have body A, body B, and body C. It says that body A is in neutral equilibrium, body B is in unstable equilibrium, and body C is in stable equilibrium. So we want to select which of these would be true based on our observation. So again, question 9 is up, so you can select your choices. So I'm going to give persons a few minutes to select their choice. And again, for persons who wish to, you can weigh in the comment section. For persons who just joined, if you wish to participate via the interactive window, there's a link in the description which you can click, which will take you to the section so you can select your option. So I'm getting some responses. Some persons are selecting option A as the correct answer. Also option C. All right, so I'm going to give persons a few more seconds to select their choice, and then we're going to discuss. All right, so the majority selecting option A, which says 2 only. So let's see now. So it says body A is in neutral equilibrium. So body A is in fact in stable equilibrium, right? Because it is not able to be displaced. Once you apply a force to it, it will not be displaced. It will in fact return to its equilibrium position. So body A is in stable equilibrium. Body B is in unstable equilibrium. Right? So body B is unstable, right? And body C is in fact in neutral equilibrium. So based on our options, so body A is in neutral equilibrium, this is false. Body B is in unstable, this is true. Body C is in stable equilibrium, this is not true. So our correct answer then now would be, hold on a second. So we don't have, let me go through this again. Okay, so our correct answer then now would be A, 2 only. So that's number 9. Now we're on to question 10. So let me go here. So question 10 says a vehicle is moving with uniform velocity of 10 meters per second. This may be represented by which of the following graphs? So we have these 3 graphs. Let me just zoom out so we can see all 3 graphs. So these are the 3 graphs for the object moving with uniform velocity of 10 meters per second. So you can select your option for question 10, and then we're going to discuss. All right, so I'm seeing persons selecting option B. All right, it's going to give a few more seconds, and you can select your options. All right, so most persons selecting B, some persons selecting A. Right. All right, so let's look at this. So it says we have a vehicle moving at uniform velocity of 10 meters per second. All right, so we have uniform velocity. All right, now we want to know which of these graphs would actually show that. So we see our graphs right here, and first of all, we should observe that our graphs here show x plotted against t. right? Which is in fact distance plotted against time, right? So distance plotted against time. So we should recall that if we have a graph of distance against time, the slope of that graph would give us the speed, right? So the slope of that graph would give us the speed. In this case, now we're asked for the velocity, but we can assume that, okay, if the magnitude of the velocity, which can be represented as the speed, we can consider the object moving in a straight line, and in fact, the speed and the velocity would be equal in terms of magnitude. So in this case now, we see that we have these graphs right here. So we have A, B, and C. Now, we have a positive value for the velocity, so we should expect a positive slope. So we have C, which is a negative slope, so we can eliminate option C, right? Option B now, in fact, we see that we have a straight line, straight horizontal line, and we should recall that the slope of a straight horizontal line or a horizontal line is always 0. So the slope of this line would be 0, right? So therefore, we can also eliminate option B. So we're down to option A and option D. So it says that it was moving with a uniform velocity of 10 meters per second. Now, if you look at option A, if you take the slope of the graph of A, right? If we take the slope of the graph of A, we're going to see that we're going to get a gradient or a slope of 10 meter per second. So in fact, our correct answer then now would be option A. So we're going to go with A for question 10. All right, so if you selected option A, well done. What's happening? Okay. It's 10. 1 second. 11, okay. That page was duplicated. Okay, so we're on to question 11. So let me go forward. So question 11 now says an object is thrown vertically upwards at the highest point. Which of the following is/are true? So it says that its velocity is 0. It is accelerating downwards. No net force is acting. So you can select your options for 11. You can use the interactive environment, or you can post the option in the chat so we can keep the chat active. And if you're finding this helpful so far, as we go through these questions, just give me a thumbs up or a reaction in the chat to let me know that you're finding this helpful. All right, so I'm getting persons selecting options C and B. All right, seeing persons commenting A as well. All right, so let's see. So it says that when we throw an object vertically upwards at the highest point, which of the following would be true? So at the highest point, its velocity will indeed be 0. So 1 is true. Option 2, it is accelerating downwards. So at the highest point, right? At the highest point, what we're going to see now is that, as we said before, it would have a velocity of 0 at the highest point, because if you think about it, so we throw the object upward, right? As it moves up, right, it slows down gradually due to the influence of gravity. So once it reaches the maximum point, at the top right here, its velocity v would be equal to 0. Now, Upon reaching the maximum point, we're going to now experience a downward acceleration. So the object is going to start to fall downward. So now we can then say that, okay, at the maximum point, it's going to have a downward acceleration. And in fact, its acceleration is always directed downward since it is under the influence of gravity. Now, option 3 says that there is no net force acting. So if we say that it is accelerating, then there must be a net force, right? And the force would be the force due to gravity. So we're going to select option 3 as well. So we're going to go with 1, 2, 1, 3 for this one, right? So if persons have question regarding this, let me know before we proceed. Oh, wait a second. Sorry, C3 says no net force is acting, right? So again, we said that there's a force of gravity. So in fact, this one is actually false, right? So the answer then no will just be 1 and 2. So we're going to go with B for that one, right? Yes, so we're going to go with B for that one. Yes, so right? So we're going to go with B for that one. So are we all clear with this? All right, so we now go to question 12. All right, so question 12 says the mass of a rifle is 100 times the mass of its bullet. If the recoil speed of the rifle is v, then the speed of the bullet is. So question 12, you can select your options for question 12. All right. Apologies for that. I had to take a call. All right. So let's continue. So let's see what persons were saying for this. So persons were saying option D. So let's see this now. All right. So it says that the mass of the rifle is 100 times the mass of its bullet. If the recoil speed of the rifle is v, then the speed of the bullet is. All right. So for this case, we can take into consideration the conservation of linear momentum. So we should recognize that when the bullet is fired from the gun, so if we consider, say, the gun, I don't know, something like that, right? It fires the bullet, and the bullet escapes the barrel. So that is the bullet, escapes the barrel, and the gun recoils, right? So the gun recoils with a velocity of v, right? Or speed v, as it says in the question. Now we want to know, okay, what would be the speed of the bullet, right? So we want to know the speed of the bullet. Let's say we call that v2, and this is v1. Now we can look at this question intuitively. So we should know that before the bullet is fired, the gun and the bullet will have a total momentum of 0 because they both are going to be stationary. Now, the principle of conservation of linear momentum says that the total momentum before is always equal to the total momentum after, right? So the total momentum before, which is 0, must equal to the total momentum after. So what it means is that the momentum of the bullet and the momentum of the gun must be equal. Now, since the mass of the rifle is 100 times the mass of the bullet, right? And the bullet, the gun recoils with a speed of v, then we should expect that the speed of the bullet should be 100 times the speed of the rifle. So what we're going to see then now is that our best answer in this case will be option C. So we're going to go with C for that one. All right, so that's question 12. All right, so we continue with question 13. Which of the following is an example of Newton's first law of motion? All right, so question 13 is up. An object falling freely in a vacuum, an object moving at constant speed in a circle, or an object being pulled along a rough surface with a constant velocity. So you can indicate your answer for question 13, I should say, and then we're going to go through. All right, so you can give your thoughts for question 13. All right, so I'm getting responses for C. Right, so let's see now. So it says an object falling freely in a vacuum. Right, so we should remember that Newton's first law says that an object at rest will stay at rest, but an object in motion will continue its state of motion unless it is acted upon by a net force. So in this case, now with the object falling in a vacuum, it's gonna continue falling straight down, right? With constant velocity, right? It's going to fall straight down with constant velocity. So therefore, this, in fact, would obey Newton's first law. Second option says that an object moving at constant speed in a circle. Now, Newton's first law suggests that the object will move, as I said, with constant velocity in a straight line. So in this case now, because the object is moving in a circle, there is a net force acting on it. And that net force is always directed to the center of that circle. So let's say we have a stone that is moving around in a circle like this. There's going to be a force acting towards the center, which we call our centripetal force, right? So this one would not be true, right? So since we would have eliminated option 2, it means in that A is out, C is out, right? And we selected 1 to be true, so therefore, best answer would be D, 1 and 3 only, right? So we're going to go with option D for this one. So we'll go with D right there. Right, and again, as we go through, if persons are having questions about anything that we discuss, please feel free to let me know. You can utilize the chat area and we will address those concerns. All right, so question 14 now. Let's go next. Question 14 says, for a swinging pendulum, which of the following is true when it is at its lowest point during an oscillation? So in this case, again, we have our options, so you can select for question 14. All right, so I'm getting responses for A. So at the lowest point, right, potential energy will be at a minimum, kinetic energy at a maximum. That is correct. So we'll go with A for that. Number 15 now. Let's go to 15. Some persons were selecting option C, right? Again, it says the lowest point, so we have to look out for those key terms. Which is basically when it's at the bottom, it's going to have the lowest height. So the potential energy must be the lowest, and its kinetic energy is going to be at a maximum because it's going to have maximum velocity. All right, so question 15 now. Let's look at that one. Question 15. All right, so while we look at question 15, it says a body of mass m moves with a velocity v and has a certain kinetic energy. With what velocity will a body of twice this mass have to move in order to gain the same kinetic energy? So we have our options A, B, C, and D. So you can select your option, right? And again, for persons who are not able to utilize the interactive window, you can utilize the chat. Just keep the chat active. So you can post your answers there, ask your questions. I will regularly check the chat to see if persons have any questions. All right, so we'll see we're getting responses for D. All right, so let me give maybe about 10 more seconds and then we're going to start going through. All right, so it says a body of mass m moves with a velocity v and has a certain kinetic energy. And we want to know with what velocity would a body of twice this mass have to move in order to gain the same kinetic energy. All right, so let's take an in-depth approach for this question. So we can recall that the kinetic energy of a body is equal to a half mv squared. That's how we can calculate the kinetic energy of a body, a half mv squared. Now we're saying that we have an object of mass m moving with a velocity v, right? and it has a certain kinetic energy. Let's say we call that kinetic energy E. Right? Now we want to know with what velocity would a body of twice this mass have to move in order to gain the same kinetic energy. So we can say that our second object has a mass of 2m. Let's say we call that 2m because it is twice the mass of the first object. Now we're saying that we want to consider both objects having the same kinetic energy. So the kinetic energy of object 1, let's say we denote it that way. So let's say we say kinetic energy of object 1, E1, or we could say KE1 is equal to KE2. Now for object 1, its mass is m and its velocity is v. And again, the kinetic energy is given by a half mv squared. So we're going to say mv squared, let's say over 2, must be equal to the mass of the second object, which is 2m. So we can say 2m, since its mass is twice our first object. Now its velocity is unknown, right? So let's say we call its velocity, so we call it vx, right? Vx for some unknown velocity, right? And again, we have to square that and then divide by 2. So we can simplify this to get closer to an answer. So we see we have m common, so let's cancel the m's, right? This 2 in the denominator is common right here, so we can cancel that. So we get v squared then now would be equal to 2 times vx squared. Now to make vx a subject, let's say we put vx on the left side. So vx squared would be equal to, so we're going to divide both sides by 2, so we're going to get v squared over 2. Now, we're interested in finding v, which is the velocity that the object of mass 2m needs to move. So to do that, we must take a square root. So square root that, so we're going to get vx, then now is going to be equal to the square root of v squared over 2. Now, we can simplify this. So v squared, the square root of v squared is simply v, so we're going to have v over the square root of 2. So it means then that our answer in this case would be A. So we're going to go with A for that. All right. Regarding the paper 3, no, I did not get a copy of it. I did not get a copy of that paper. All right, so for question 15, we're going to go with option C for that one. Number 16 now. So let's go with that. So number 16, see what question 16 says. Oh, so question 16 says, zoom this out a bit, says A and B in the diagram above are two pistons which fit closely into the cylinders shown. Piston B has a cross-sectional area 10 times that of piston A. Piston A is used to apply an excess pressure P on the liquid under it. The excess pressure of the bottom of piston B is, and we have our options. So again, you can select your options for question 16. Again, you can use the chat, post in the chat, and then we will discuss. Right, so you can select your options for question 16. Again, you can use the interactive environment as well as you can use the chat. Let's keep the chat going. And again, if you're getting value from this, you can give me some reactions. Use up the emojis, use up the hearts if this is being helpful for you. All right, so I'm getting responses for C. All right, so let's see what's taking place right here. So we have this arrangement right here. Now it says that piston A applies an excess pressure P to the liquid under it, and we want to know what is the excess pressure at the bottom of piston B. Now, we should recall that once piston piston A applies that excess pressure, that excess pressure will be transmitted throughout throughout this fluid, in this case the oil. So what we're going to see now is that the pressure, excess pressure due to piston A, is going to be the same pressure that is going to be exerted on piston B right here. So what we see then now is that the pressure at piston B is going to be the same as that of piston A. So the pressure therefore now will just be P. Right? So our answer then now would be option B. So we'll go with B for that. All right, so that's question 16. All right, so question 16. Now we're on to question 18, which is down here. So let's zoom in. So this should be an easy question for us. It says item 17 refers to the following options, which represents 4 units used to measure different quantities. So we have the Newton, the watt, the joule, and the Pascal. Each of these may be used more than once, not at all. Answer the items below. Which of the units is used to measure kinetic energy? So we can select our answer for that for question 17. All right. I mean, that's part of why we go through and discuss. All right. So for question 17, we're getting responses for C. All right. So kinetic energy is the joule. So that is indeed correct. All right. So the joule is used to measure kinetic energy. All right. What would be for power? All right. Yes. All right. So number 18 now. Let's see where we go next. So number 18 says the diagram above shows an air column trapped in a capillary tube by a mercury pellet. When the temperature of the water bath is raised, what happens to the volume and pressure of the trapped air? All right, so we have our options right here. So again, this is question 18. You can select your options for question 18. Again, you can utilize the interactive window or you can utilize the chat. Let's keep that active. Let me zoom it a little more. This person can see what's going on. So what are we saying for question 18? A, B, C, or D? All right, so let me give 10 more seconds. Persons can select their choice, whether A, B, C, or D. All right, so person selecting option D. All right, so let's see. All right, so let's see what's happening right here. So it says that we have this thing right here with the water bath. We have an air column trapped by this mercury pellet. Now, it says when the temperature of the water bath is raised, what happens to the volume and the pressure? So we should be able to recognize that this is related to Charles' law, right? Charles' law, which relates the volume of a fixed mass of gas to its absolute temperature, right? So in this case now, as we increase the temperature, we should expect the volume to increase. So let's see our options right here. So we have A, which says that volume increases. This one says volume increases. So the answer could be either A or B, right? Now, since again we're looking at Charles' law, we can remember that for Charles' law, pressure is always constant. So in this case now, as the volume increases, the pressure will remain constant. So our answer here for now is going to be A. And again, the pressure would remain constant because the pressure exerted on the gas is due to the pressure exerted due to the weight of this mercury pellet and the cross-sectional area plus the pressure due to the atmosphere. So that pressure is going to remain constant, right? But as we increase the temperature, the volume will in fact increase. So we're going to go 18 with A, or A for 18. Number 19. Let's see, number 19 now. Number 19 says, item 19 refers to the following options: infrared rays, light rays, sound waves, water waves. In answering item 19, a particular choice may be made more than once or not at all. Which of the following, or which of the above, would have the shortest wavelength? All right, so we want to indicate which of these would have the shortest wavelength, whether it's infrared, light rays, sound waves, or water waves. All right, so again, you can give your options, whether A, B, C, or D. You can utilize the chat or utilize the interactive window. Again, the link is in the description for you to participate via the interactive window. All right, so is it A, is it B, is it C? All right, so I'm getting choices for A and C. All right. Okay. All right, so let's discuss this one. So if you look at our options right here, sound waves and water waves, I think we can eliminate those two. So sound waves, water waves, we're going to eliminate those, right? Because the wavelength of sound, it is significantly larger than infrared or light. Similarly, for water waves, right? In fact, we could argue that and again, it all depends on the frequency of the sound that will determine the wavelength. But as I said, we can eliminate options C and option D. Now, if we recall our electromagnetic spectrum, I usually like to list them this way. So G, X, U, V, I, R, right? Well, let me not go I as it. I'm not go I. Yes, we could go R for radio waves, or we could include not electromagnet, microwaves, right? These are all electromagnetic waves. Now, as we list these, we list them in order of increasing wavelength. So wavelength increases to the right. So gamma will have the shortest wavelength and radio waves would have the longest wavelength. Now, in between all of that, we have V, which is visible light, and we have I, which is infrared. Right? So what we see now is that in terms of increasing wavelength, visible light comes before infrared. So in this case, we want to know the shortest. So it goes to show that visible light, which constitute light rays, would have the shorter of the two when compared to infrared. So we're going to go with B for this one, for question 19. Right? So question 19, we will settle with B. All right, so let's continue. So question 19, or question 20 we're on now. So question 20 says a student measure the temperature of a solution using two thermometers, one calibrated using a Celsius scale and other a Kelvin scale. If the solution is heated and the temperature rises 5 degrees on the Celsius thermometer, the Kelvin thermometer will show a rise of. So let's select our answer for question 20. It's going to give you a few seconds to decide whether it's A, B, C, or D. All right, so I'm getting responses for C. Okay. All right, so let me give 10 more seconds. Persons can give their answer. Also getting option answer for B, option B. All right, so just a few more seconds and then we go. All right, so it says we have these two thermometers, Celsius and Kelvin, with a Celsius and a Kelvin scale. And we saw where the temperature on the Celsius rose by 5 degrees, right? And we want to know what would be the rise on the Kelvin thermometer. Now, in this case, now we're looking at a change in temperature, right? So a change in temperature. Now, we can remember that a change in temperature in degrees Celsius is the same change in temperature in Kelvin, right? So therefore, if the temperature in Celsius rose by 5, the temperature is going to also rise by 5 in Kelvin. So we're going to go with B for that one. Because again, we're looking at a change in temperature, right? So since it's a change in temperature, they're going to be the same. So that's B for question 20. Number 21 says that the heat capacity of a body depends on and again, just a few seconds, you can select your answer for question 21. And again, as you join, and for persons who are already here, if you are finding this helpful, let me know. Give me some energy in the chat or using the emojis. All right, so we're on to question 1. So is it A, is it B, is it C, or is it D? All right, so I'm getting persons going with B and C. So let's see our options. So it says that the heat capacity depends on, A says its mass and the specific heat capacity of the material. Its mass, B says its mass and the temperature change of the body. C says the density and the temperature of the material. And D, the density and the expansivity of the material. Now we can eliminate two options. We can eliminate C and D. So we're down to either A or B. Now we can recall a little expression which says that C is equal to MC, right? And I believe there was a question like this on the paper 2, I believe so, if I'm not mistaken, where C is the heat capacity, right? M is the mass, and C is the specific heat capacity. So what we see then now is that the heat capacity is in fact dependent on the mass as well as the specific heat capacity. So we're going to go with A for this one. That's question 21. Now, question 22 says that the units for the specific latent heat of fusion would be, so we're on question 22, so you can give your input for question 22, whether it's A, B, C, or D. All right, so let's see. So we're getting C, we're getting D, we're getting also B. So let's clear this up. All right, so it says unit for specific latent heat. All right, so specific latent heat. So once we talk about latent heat, there's no temperature involved. So anything with temperature we can ignore. Right, so we can ignore C because there's temperature, which is Kelvin. We can ignore this one as well. So we're down to A or B. Now, for the specific latent heat, we take into consideration how much heat energy is required to raise 1 kilogram. Sorry, not raise, again, latent we're talking about. So for specific latent heat, we take into consideration how much heat energy is required to change the state, right? Not to change any temperature, but to change the state of 1 kilogram of a substance. So the mass is going to be involved. So therefore, our answer we can settle with is B. Right, so we're going to go with B for this one because again, it's a specific latent heat. Right, so we have to be keen on the wording of these questions as we go through. So that's 22. 23 is up next. Let's see what 23 says. So 23 says that we have this thing right here. So the diagram above shows water boiling at the top of a glass test tube while a piece of ice remains unmelted at the bottom. Which of the following is a possible reason for this occurrence? And we have our options right here. So again, we just zoom out so persons can see this. And you can select your option, whether A, B, C, or D. Right, so I'm getting some responses. All right, so I'm getting persons selecting option B. Option B says that water is a poor conductor of heat, and B is in fact correct. So that's 23. Now we're on to 24. So 24 says that which of the following occurs when one end of a metal rod is heated? One says hot molecule move down the rod, electrons move down the rod carrying energy, and 3 says thermal energy passes from one molecule to the next. So we can respond to option 24. I'm going to give 15 more seconds for persons to lock in their answers, and then we will continue. All right, so question 24, we're getting options, responses. We're getting options for B and C. So let's see which of the following occurs when one end of a metal rod is heated. Now we can recall that energy is transferred through a metal by the means of conduction. Now for conduction, we have to recall that it involves no movement of molecules of the substance, right? So there's no movement of molecules of the substance. In fact, what happens, because for the solid, for instance a metal, which is a solid, the particles are tightly packed. So since they're tightly packed, they're able to vibrate. They're able to vibrate about their fixed position. Now when we heat those particles at one end, what happens is that they start to vibrate faster. Now that faster vibration creates a chain reaction. So the adjacent molecules start to vibrate faster, and eventually all the molecules along the length of the metal are vibrating faster. So that's one means by which heat is transferred through a conductor. Now in this case now for the metal, which is what we're looking at, we also have those free electrons that can move about, right, throughout the lattice of the metal. So what we see now is that when heat is transferred through a metal rod, as what we have right here, it is due to the particles transferring the thermal energy from one molecule to the next. So the molecules themselves, they're not moving, they just, in fact, as I said, vibrate, right? Which creates a chain reaction, plus we have those electrons that can actually move about. So we're going to see that options 2, right, and option 3 will be valid. So our answer then now, we're going to lock it in as option C. So we'll go with C for that. Now for 25. 25 says that if the molecules of a gas have less space in which to move, then the number of collisions per second with the walls of the container is increased. This statement explains, and again we're on to 25, so we can lock in our answers for 25. Alright, so we can lock in the answers for question 25. Alright, so I'm getting persons responding. Alright, so let's see. So we see that, okay, the molecules have less space. So the volume is what we're looking at. So we have the volume, right? And we now talk about the number of collisions per second. Now, number of collisions per second will give a representation of the pressure. So we have the volume and the pressure being investigated. Now, the gas law that relates volume and pressure, we can recall is Boyle's law. So we're going to go with A, Boyle's law, right? So 25 is A. So for the persons who selected A, well done. Number 26 is what we are next. So 26 says, which of the following is not implied by the kinetic theory? So we have our options right here. So let's give you a few seconds to input your answer. Alright, so just a few more seconds. Question 26 is what we are at now. So you can lock in your answers A, B, C, or D. Alright, so 26, what are we saying for 26? Alright, so I'm getting options for C. Alright, so let's see this now. So it says which of these is not implied? Right? So the internal energy of a gas depends only on the gas temperature. The pressure of the gas is caused by a change in momentum of the molecules bombarding the containing surface. The kinetic energy is the same for all particles. There are strong intermolecular forces between two molecules close to each other. So the one that is not implied, as the question is asking for, would be C, which says that the kinetic energy of all the particles are the same. That is not true. Hence why we talk about the average kinetic energy of the particles. So our correct answer then now would be C, right? Because everything else is in fact implied by the kinetic theory. So the persons who selected C, good work. So we're on to 27 now. So let's skip this one, 27. So item 27 refers to the following displacement time graph of a water wave. So we have displacement on the y and we have time on the x. Now the question says, now what is the frequency of the wave? So let's lock in our answer for 27. Let's lock in our answer for 27. Again, if you're finding this helpful and you wish to share with your friends, please share the link with them so that they can join and be a part. Alright, so we're getting some responses so far, getting option C being selected. So the question is asking us to determine the frequency. Now the frequency is the number of oscillations completed in 1 second. Now in this case now, we are given the displacement on the y and the time on the x. And we can use that information to determine the time taken for one oscillation, right, which is represented by that. So the time taken for one oscillation, which we know describes the period, is 0.2 seconds. That would be our period. But the question wants us to find the frequency. Now the frequency is the inverse of the period, or 1 over the period, so we can say 1 divided by 0.2 seconds, which would in fact give us 5 hertz. So 27 is indeed C. So good work again, 27. Now we're on to 28. It says that which of the following statements about sound waves, water waves, and electromagnetic waves is not correct? So we're on to 28, where the option is A, B, C, or D. You can indicate your option for 28. Alright, so I'm going to allow a few more seconds so persons can lock their answers in. Alright, so let's see this now. So 28 says, which of the following statements about sound waves, water waves, and electromagnetic waves is not correct? So let's see now. So it says that they're all transmit energy from the source to the surroundings. This is true. They are all examples of transverse waves. So sound waves, we can recall, is longitudinal, right? Water waves are longitudinal, and electromagnetic waves, sorry, water waves are transverse. My bad. Still locked in on the sound. So sound waves are longitudinal, water waves are transverse, and electromagnetic waves are also transverse. So they are all not examples of transverse waves. So this statement is not correct, right? So again, let me just uncheck that one. So this is a true statement, right? So this is true. They all undergo reflection. This is true. They all travel at, they have different speed of propagation. This is true. So our false statement is this one. So our answer then now is B, right? So hopefully we clear that up. So 28 is B. So persons were able to find that answer. So good work. 29 is what we're at now. So we are almost halfway through the paper. 29 says, which of the following would give the refractive index for light traveling from air to glass? And we have our options right here. We have our options here, so we can select question 29, whether it's A, B, C, or D. Alright, so you can lock in your answer, A, B, C, or D, for this question. Alright, so I'm seeing persons giving their own answer, option C. So let us discuss. So we want to find the refractive index. Now, the refractive index, by definition, N is the speed of light in a vacuum or air. Right? But the speed of light in a vacuum is the same as that in air. So let's use speed of light in a vacuum C over the speed of light in the medium. Alright, so in this case now we're talking about glass. So it's going to be the speed of light in air divided by the speed of light in the glass. So let's see now. So we have speed of light in glass over speed of light in air. This is not so. So we eliminate that one. 2 says the wavelength of light in air over the wavelength of light in glass. So let's just recall that for a wave, its speed, V, is the frequency multiplied by the wavelength, lambda. So in this case, we can see that we can determine the refractive index by taking into consideration the wavelength, right? The wavelength of the light in air and the wavelength of light in the glass. So this one would be a valid expression that we can use to find the refractive index. Now option 3 says that we can use the frequency of light in air over the frequency of light in the glass. Now if we go back to our formula right here, we see that the speed is frequency times the wavelength. Now one thing we need to recall, for any wave traveling between two different mediums, the frequency is always constant, right? So for a wave traveling between any two mediums, the frequency is always the same, right? So as a result of that, we cannot use the frequency when determining the refractive index. So therefore our only option that we can go with would be option 2, which corresponds to A. So we're going to go with A for 29. All right, so good attempt with that one. All right, so 29 would be A. Number 30 now, down the line, says that some water in a container shown is brought up to its boiling point by an immersion heater. A watch is then started and the time t to boil off a mass m of water is found. If the heater has a power P, the specific latent heat of vaporization is, so we have question 20, which is 36, 29. I think I missed out some questions. I think I would have missed out some questions. Alright, some questions are missing from this. So let's move forward to 36. Alright. So we're missing some questions from this. So we're going to jump from 29 to 36. So we're missing about 7 questions. Alright, so let's see this now. So we have this right here. We want to know the specific latent heat of vaporization. So which of these would be our answer? So you guys can lock in your answer for this question, 36. When I got this paper, I didn't get the here for it, so I'm not too certain what here. Some of these questions, might be are new to you, but hopefully as we go through, you are able to get a deeper appreciation for the questions and be able to appreciate the questions as we discuss. All right, so 36, what are we saying for 36? A, B, C, or D? All right, so we're getting some answers. So let's see this now. So we want to find the specific latent heat of vaporization. So, so as I said, we have time t and a certain mass m is boiled off and the heat has a power p. So we can recall that energy is equal to m l v, where LV is the specific latent heat of vaporization. So LV then now is going to be equal to E over M. But energy can be calculated by multiplying the power of the heater by the time. So we get PT over M, which confirms our answer as A. So 36 is A. 37 now says, we have this diagram right here. Let me skip forward to 37. 37 says that from the diagram above, a real image is produced when with a converging lens when the object is located. So we have our options right here. So we're going to give you some time to lock your answers in for this one. For number 37. Alright, so what are we saying for 37? So persons are saying, okay. Alright, so we want to form our real image. Alright, so we can get a real image once the object is between F and infinity. So B is indeed correct for 37. So we'll go next to 38. So let's go forward. So 37 would be B, right? If it's at F, we're going to get a real image, but we can also get F at distance greater than the principal focus, right? So that's 38. No, 38 we're at now. We're at number 38. So 38 says that in the diagram above, F represents the principal focus of a lens. Right? So F is our principal focus right here. Which line represents the ray of light after passing through the lens? So let's take a moment to look at this and we can select our answer for this one. Alright, so I'm going to give you a few minutes to select your answer, whether it's A, B, C, or D. Oh yes, audio, is audio good now? Do we have audio? Can someone just confirm audio? Okay, perfect, thank you. All right, so what I was saying earlier is that we have a convex lens right here. So this ray xg, because it continues straight, the only way the ray will continue straight is if it passes through the optical center, which is what I was indicating right here. So xg is false. If we look at xf now, xf passes through the principal focus at this point. Now, the only way that passes through the principal focus after it passes through a convex lens is a ray that was originally parallel to the principal axis. So this ray was not parallel, so we would not expect this to be the case. So xf is going to be eliminated as well. So we're down to either, what are we down to? We're down to either xh or xf. Now, in this case, if we just look at what's taking place right here, so we have this lens right here, this converging lens. it's going to cause the light rays to meet at a point. And again, as we said, if the ray was parallel, it's going to pass through the principal focus. So in this case now, we would not be able to expect XF to be formed, right? So XF will not be formed because again, when the ray is parallel, it's going to pass through the principal focus, right? So this ray will not be formed because in fact, for this ray to be formed, the object must be from a point less than the focal length. So XF is not practical either. So our only option then now has to be XH, which is option B. So A is also not true. What is F or E this? I guess it's probably E. So 38 would be D as in dog. So we'll go with D for number 38. So I saw some person getting that correct. Good work. All right, 39 is where we are next. Let's find that question. So 39 says, when a polythene rod is rubbed with a cloth, it becomes... So let's lock in some answers for 39. All right, so getting some responses. All right, so I'm getting C. Someone's person responding C, okay. Also getting A. All right, so let's look at our options right here. So it says a polythene rod is rubbed with a cloth and it becomes... So whenever we get a question like this, only thing that we should be interested in is the electrons, because whenever we're charging an object, it is always due to the movement of electrons. So anything with protons we can eliminate. So A eliminated, D is also eliminated. Now, since we're zoning in on the electrons now, we can recall that electrons are negatively charged, right? Electrons are negatively charged. So in this case now again, we also have to know a little further, because if you notice B says becomes positively charged by losing electrons, that could be true. C says negatively charged by gaining electrons, that could also be true, right? But what we need to recall is the property of the polythene rod and the cloth. Now polythene rod, it's a type of plastic, and polythene, it is more electronegative, right? So it is it electronegative? Let me put it in simpler terms. So the polythene rod, it is more reluctant to give up electrons, right? So the polythene rod, it is more reluctant to give up electrons. So it has a greater affinity for electrons, as opposed to the cloth, which does not have that high affinity or that high willingness to hold on to electrons. So what we're going to see now is that we're going to have electrons being transferred from the cloth to the polythene rod, right? So the polythene rod is going to gain electrons, and if it gains electrons, it's going to become negatively charged. So our answer then now would be C. All right, so some persons were able to get C, so good work. All right, number 40 now says a transformer is used to. So a transformer, right, is used to. So that's 40. So let's go forward. So number 40. So you can lock your answers in for question 40. All right, so question 40, is it A, is it B, or is it C? Okay, so we're getting responses for C, for number 40. So transformer is indeed used to alter voltage. So we go with C straight away. Alright, so that's another good one. 41 now says, which of the following is true of the SI unit of electric current? So 41, let's see what we can do for question 41. Are we going to go with A? Are we going to go with B? Are we going to go with C? Or are we going to go with D? Alright, so what are we saying about question 41? A, okay? Some person saying A. So let's see which of the following is true of the SI unit of electric current. Alright, so one says it is called a coulomb. So we can just remember electric current, SI unit is the ampere. Right? So not the coulomb. Right? So one is not true. Two says it is defined in terms of the force between two current carrying wires. Right? Not sure if we're sure about that, but let's come back to it. 3 says it is named after a scientist. So we said that it's the ampere. It is indeed named after a scientist. So 3 is true. Now, by the process of elimination, we said that 1 is false. So anything with 1, you can just scratch it out like that. And we're going to be left with C. Now, option 2 says that it is defined in terms of the force between two current carrying wires. And this is in fact true because the ampere is indeed defined in terms of the force between two current carrying wires that are 1 meter apart. So our answer then now for 41 would be C. Alright, so we're now on to 42. 42 says an electronic flash discharges in 1 millisecond. Sorry, an electronic flash which discharges in 1 millisecond passes 0.05 coulombs of charge in this time. What is the average current that flows? So let's attempt this one for 42 and see what we can come up with for question 42. All right, so 42 is where we are. What are we saying about 42? A, B, C, or D? All right, so persons are saying D. All right, a few more seconds. Persons want to lock their answer in. Again, we're going through this interactively. So as you participate, you'll be able to clear up any misconception that you may have or validate your answers as we go through. All right, so let's go through this one. So it says an electronic flash which discharges in 1 millisecond passes 0.05 coulombs of charge in this time, and we want to know the average current. So if we recall that we can calculate current by the rate of flow of charge, which is simply the charge, quantity of charge divided by the time. So the quantity of charge is 0.05 coulomb, and the time is 1 millisecond. So that's 1 times 10 to the minus 3 second. Or we can write this as, let's put both of them in SIU in standard form, I should say. So this would be 5 times 10 to the minus 2 divided by 1 times 10 to the minus 3. So this now becomes 5 times 10 to the minus 2. So we're dividing by 1. So 5 divided by 1 is just 5. Now, since we have 10 to the minus 2 in the numerator, 10 to the minus 3 in the denominator, this is going to become 10 to the minus 2 minus 3, or simply 5 times 10 to the minus 2 plus 3, which is the same thing as 5 times 10 to the 1, right? 10 to the 1 is just 10, so 5 times 10 is just 50. So we have to go with B for this one, right? So for 42, go with B. Some person selected B, so good work to you. 43 is where we are now. So 43 says that a beam of light passes from one medium to another of greater refractive index. When it refracts, so we're at 43. So you can lock in your answer, A, B, C, or D. Yes, can use your calculators. For the paper one, you have the ability to use your calculator, so don't be afraid to use them up when you have to do your calculations. All right, so 43, what are we saying for 43? Can we decide on an answer? All right, so some person is going with D. Okay. All right, so let's see this now. So person selecting D for this question. So let's go through. A beam of light passes from one medium to another of greater refractive index. When it refracts all right, so we said earlier that the frequency never changes, so we know that this is not so. The wavelength changes, right? We're going to come back to that. The speed increases, or the beam bends away from the normal. Now, in this case, we're going from one medium to one of a greater refractive index. So we're going from a less dense medium to a more dense medium. So if we're going to a more dense medium, we expect the speed to decrease. So the speed will decrease and not increase, so this is false. Now also, as the ray slows down, or the light slows down, we expect it to bend towards the normal. So this one says it bends away from the normal, so this is false. So the only correct answer is that the wavelength changes, which is B. Right? So that's 43. 44 now. Let's go to that one. So 44 says that the critical angle for material of refractive index 2 is. So let's see what we can get for this one. Number 44. So number 44, is it A, is it B, is it C, or is it D? Let's lock in our answer. So we're getting some person saying B, right? So you can utilize the interactive window on screen so we can see the charts, or if you wish to use the chat, you may use that to lock your answers in. Right, anybody else wants to give their input on question 44? Right? So everybody else is unaware or unsure. All right, so 44, let's see, so it says the critical angle of a material of refractive index 2 is. All right, so we can recall that the sine of the critical angle, all right, is equal to 1 over the refractive index. Now in this case now, we're told that the refractive index is 2, and we want to find the critical angle. So the sine of C is going to equal to 1 over 2. So sine C is going to equal to 0.5. So C now is going to equal to the inverse sine inverse of 0.5. Now if we evaluate the inverse of sine, we should expect to get 30, right? So our answer then now would be C, which is 30. That was 44. Number 45 now. It says a student requires a circuit to measure the resistance of a resistor. Which of the circuits below is correctly connected? So let's take a look at the circuits. So which of these circuits would be used to measure the resistance, or can be used to measure the resistance of a resistor? So that's 45. So you can lock your answers in for question 45. So again, we're looking at which circuit can be used to measure the resistance of the resistor. So we're looking at to see, okay, which circuit is connected correctly from the list that we have right here. So no, okay. So getting some responses. So for the others, don't be afraid to share your thoughts. Right, we're going to discuss all questions so that you can get clarity. All right, so we're getting some responses for B, getting also for A. All right, so we're going to discuss all of those. All right, so a few more seconds. All right, so this is where we're at. All right, so we want to know which one can be used to measure the resistance of the resistor. So for the circuit, we're going to be needing the voltmeter and the ammeter. Now, we should recall that the ammeter is always connected in series with the component, and the voltmeter is connected parallel. Right, so we're going to use the ammeter to measure the current and the voltmeter to measure the potential difference. Because you can remember from Ohm's law, V is equal to I times R. So R must be equal to V over I. So we're going to need to know V and we're going to need to know I. So we need to use these instruments right here. So again, ammeter in series, voltmeter in parallel. So we're just going to look for that to see where that is the case. So here the ammeter is connected parallel. So we're going to eliminate A, right, for that. B, ammeter is connected in series, but the voltmeter is also connected in series. So we have to eliminate B, right? Now, if we look at C, we have the ammeter connected in series and the voltmeter connected parallel to the resistor. So we can go with C for this one. So 45 would be option C. All right, so that's 45. So we're now to 46. So 46 says that which of the following statements is / are true concerning a domestic wiring system? So we have our options right here. So we can read through these and then decide which of these we're going to go with, A, B, C, or D. So again, just a few seconds to lock your answers in, and then we can discuss. So we're on to question 46. Again, you can share with your friends, your schoolmates, so that they can join and take part in the session as we are going through. Almost through with this paper. I'm planning to go through another one right after. So it would be extremely beneficial for others to be aware, so you can share the link with them so that they can be a part. All right, so let's go through these. So we're getting person selecting D for this one. So which of these will be true? So switches are always connected in the live wire. Yes, that's true. Fuses are included to prevent short circuiting. Right, we're going to come back to that. The lights are connected in parallel to one another. So we know that this is true. So 1 and 3 are true, right? So 1 and 3 are true. So it means then that option C, we can eliminate option C, right? And we can eliminate option A, right? Now, option 2 says that fuses are included to prevent short circuiting. Now, a short circuit occurs when electric current has a path of zero resistance. Now, when that occurs, we're going to have a very high current flowing. Now, that can result in fires because you're going to have a very large current flowing, which can cause the wires to heat up significantly and can even cause the wires to start to heat up so much that they actually start to burn and cause a fire. So oftentimes we utilize fuses in certain instruments so that if there's an excess current due to a short circuit, the fuse can basically break the circuit, because that's what the function of a fuse is, to break a circuit once there's an excess current. So while we use a fuse to ensure that if there's a short circuit, the appliance is not damaged by an excess current. A fuse does not prevent short circuiting, right? So the fuse, as I said, it helps to protect the device in the event of a short circuit, right? So option 2, we can consider that to be not true. So therefore, we would have to eliminate D. So our answer then now is going to be option B. So we settle with B for 46. Right? So number 47 now says we have the circuit right here. So in the circuit shown above, which lamps will be lit when the switch is closed? So let's look at this. Take a close look at it. And we want to decide which lamp will be lit when the switch is closed. So that's 47. So giving you some time to lock your answer in, and then we will proceed. All right, so 47, A, B, C, or D. What are we saying for this one? You can indicate in the chat, or you can utilize the interactive environment. All right, so we're getting some answers already. All right, so remember to give your thoughts, what you think this would be, so we can discuss. All right, so we're getting options for A, B, and C. All right, so let's see what's taking place with the circuit right here. So I have the circuit with this lamp R, P, and Q. We have this battery right here, and we have this switch. So they want us to know what's going to happen, or they want to know what's going to happen when we close this switch. Now, when we close the switch right here, right, we are now incorporating lamp Q in the circuit, right? But there's one thing that we need to always remember about electric current, right? And that is electricity takes the path of least resistance, right? So electricity always takes the path of least resistance. So once we close the switch right here, yes, we're going to include the lamp Q in the circuit. But notice that there's this wire right here, or this pathway right here. Now, this pathway, because it's just a straight wire, will have zero resistance. Okay, so even though we close the switch right here, the current will not flow through lamp Q because of this path of zero resistance. So the current is going to flow around, right, like that. So it's as if Q is not a part of the circuit, right? Now for the other lamps now, we have lamp P. Current only have this path to flow, so it has to flow through P. Similarly, it will also flow through R. So then, what we see then now is that only lamps P and R will be lit. So only P and R, which would be option C. So this question, we're going to go with C for that one. So good work to you if you're able to recognize that one. So that's 47. So we're on to 48 now. So 48 says that the PN junction is used as a semiconductor diode. Yes, that's true. Which of the circuits below is the equivalent of the diagram above and also shows the correct direction of electron flow? All right, so let's see what we can say about this one. All right, let's see what we can say about this one. So I want to know which circuit is the same as the one above and which one shows the direction of electron flow. All right, so let's make a choice for 48. A, B, C, or D. All right, so feel free to, as I said, give your choices, whether A, B, C, or D, so we can discuss. Again, you can utilize the chat section, or you can utilize the interactive window via the link in the description of the in the description. Right, any choices for 48? Okay. Yes. And the thing is, when I zoom in, you're not going to be able to see the options. All right. All right. So let's go through this one, just for the sake of that. All right. So it says that the PN junction is used as a semiconductor diode, and we have our semiconductor diode right here. And they want us to say which one is similar to the circuit above. Now, with our semiconductor diode, we have to be able to identify that this end is the positive and this end is the negative, right? So the positive end usually consists of a p-type semiconductor, and the negative end consists of an n-type semiconductor. So we're going to have p on the left, n on the right. So then the circuits that show that includes A and B, right? But in this case, now we want to show electron flow. So we have to remember that electron flow consists the flow of charge from the negative terminal to the positive. So this is negative and this is positive. So electron flow, right? We're going to have charges flowing in this direction. So our correct answer therefore now would have to be option A. So that's 48. Now 49, right? 49 says that the following diagram represent possible traces on the screen of a cathode ray oscilloscope. All right, so for this question, might pose a little bit of a challenge for us, right? So let me just go into this right away. So we have this right here. Now it says, which of the diagrams best represents an alternating voltage applied to the Y plates with the time base off? So we can consider that with the time base off, we're not going to have any horizontal sweep on the oscilloscope. So we're not going to get any measurement in the horizontal plane, right? But since we apply the voltage to the Y plates, we're going to get a reading on the vertical plate. So therefore, now the best option that actually shows that is option A. So we're going to get a reading along the vertical of the oscilloscope, but we're not going to get anything on the horizontal because there's no horizontal sweep in order to detect the reading horizontally. So for 49, we're going to go with A. So that's that. Hopefully we can settle with that one. So number 50 now. Let's go to that one. So 50 says, which of the following would soft iron not be used? So number 50, let's select our choices for question 50. So is it A, is it B, or is it C, or is it D? All right, what are we saying for number? All right, so we're going with D. Okay. Oh, okay. All right, so we're getting persons going with the weird one, D. All right. So we will get a chance to see that. All right, also getting options responses for C. All right, so let's go through this. All right, so it says, for which of the following would soft iron not be used? Now, one of the things that we need to recognize about soft iron is that a soft iron is a material that can be easily magnetized, right? But it does not retain its magnetism very well. So as we look at these options right here, we can think to say, okay, which of these instruments right here, which of these would work best, right? Which of these are, let me in the case of since we're asking for not, which of these would not work best with a material that can be magnetized easily but does not retain its magnetism very well? So if you look at our options right here, so we have a magnetic keeper, which is just a device used to store magnets, right? So it is used to store magnets such that they don't lose their magnetism. Now, an electromagnet is a device that is used to behave as a magnet when an electric current actually passes through it. Now, for this particular case with an electromagnet, we need it to be such that it is responsive in the sense that, okay, when there's a current, it has magnetic properties. But when there's no current, it has no magnetic properties. So we need something that can be magnetized easily. So a soft iron in that case will be best suited for that. Now, a magnetic shield, right, is essentially just a device used to deflect magnetic field lines by basically absorbing those magnetic field lines. So in a case like that, soft iron would be a good option to use. Now, Dino says a compass needle. Now, a compass needle, you always want it to be magnetized, right? So you want something that can retain its magnetism very well, right? So the compass needle would not be suited to use for the soft iron to be used, because as soon as it is magnetized, it's gonna lose its magnetism because it does not retain its magnetism very well. So D is what we're gonna settle with as our answer for number 50. All right, so number 51 now says that item 51 refers to the following diagram, which shows a coil carrying a current. Oh, I need to skip the page. So 51 is that. Coil carrying a current and wrapped around a wooden cylinder. Which row of the table below shows the magnetic field directions at X, Y, and Z? So let's zoom out a little bit. So we have this right here for 51. So let's lock in some answers for 51. Is it A? Is it B? Or is it C? Or is it D? All right, so we're into 51. So let's select some answers for 51. All right, so we're getting option for A. Okay. All right, so just a few more seconds and then we're going to start going through. All right, so we're getting A for that one. All right, so we're also getting C. All right, so let's go through. All right, so it says which row shows the magnetic field directions at X, Y, and Z. All right, so for this, we can take a close look as to what's going on. So we have our coil, right, represented by the wire right there, and we're showing the direction of the current. So we see that the current at this end is flowing, we could say, in a clockwise direction. So the current is flowing clockwise right here, and here it is flowing anti-clockwise. And the reason why I pointed that out, so again, this is clockwise, so let's say clockwise, and this is anti-clockwise, right? Almost the anti-clockwise moment. But anyways, we have this going clockwise, because again, the current is coming down, it's going to loop back up, so it's going to be going in a clockwise direction. If it is that we place our eye at this point right here and look down into this coil right here. As we look down into this coil, we're going to see the current going in a clockwise direction. Now, as I said, the reason why I point that out is because once we have current flowing clockwise, right, at the end of a solenoid, right, at the end of a solenoid as to what we have right here, that end will always be represented, or that end will always behave as a south pole. So this is going to be our south pole like that. So if this is the south pole, then this one naturally will be the north pole. So we have the south pole right here and we have the north pole. And the reason why we need to know that is because that is going to help us to determine the field direction at the different points. So we know that magnetic field lines, they always go from the north pole to the south, right? Let's try that again. So they always go from the North Pole to the South Pole, like that. So then, what we see then now is that the field line is going to be moving. Since it's moving away from the North Pole, it's going to be going this way at Z. It's going into the South Pole, so it's going to be going that way at S. But for Y now, it's moving to the left, so it's going to be going in that direction. So we're going to have X and Z at the same direction and Y to the left. So Y is going to the left, so it's going to be any one of these three, right? And X and Z goes in the same direction, so that's going to be D. Let's just confirm it, right? So this is that is so, and then that is that. So we're going to go with D for this one. So 51 would be D. So I saw some persons selecting that for the response, so that's good. So 52 now is where we go next. So 52, where is that? This is right here. Which of the following is true when a magnet is moved relative to a coil? All right, so let's see 52 right here. All right, so okay. So we're getting some responses already. All right, persons selecting D. All right, so let's see this now. So it says, which of the following is true when a magnet is moved relative to a coil? The induced current is in the same direction as the charge, or it should be change causing it. This is not so because Lenz's law says that it is opposite direction to the change causing it. So this is false. The greater the number of turns of the coil, the smaller the induced current. That is not so. More turns, greater the induced current. So this is false. So 1 and 2 is false. So anywhere we have 1, eliminate it. Anywhere we have 2, eliminate it. So we can settle down with D, right? Which says that the faster the magnet moves relative to the coil, the greater the induced EMF. The stronger the magnetic field, the greater the induced EMF. So that's D. So 52 was D. Good work for that. 53 now, a magnetic field cannot be used to deflect. So what are we going to say for 53? What's going to be our answer for 53? All right, so what we're saying for 53? All right, so we're getting options A, option B. All right. So we're asked to indicate which of these that a magnetic field cannot be used to deflect. Now, we should recognize that a magnetic field will be able to deflect any particle that has a charge. So from our list, if we can identify the particle that has no charge, then the magnetic field will not be able to deflect that. Now, the particle right here that has no charge is our neutron. So we're going to go with the neutron, which is B. All right, so that's 53, B. So if you're able to get that one, good work. 54 is where we are now. 54 says that which of the following would induce an EMF in a conductor? All right, so let's give our option for this one. All right, so persons are going with D for this one. All right, so let's discuss. All right, so it says again that which of the following will induce an EMF in a conductor? So it says moving a magnetic field across the conductor. Right? So once there's relative motion between the magnetic field and the conductor, there's going to be an induced EMF. So that's true. Moving the conductor in the magnetic field of a magnet, yes, because there's relative motion. Placing the conductor near to a wire carrying an alternating current. Now, with a wire carrying an alternating current, it's going to cause a change in magnetic field, right? So since it's a change in magnetic field, it's going to induce a magnetic field in a in the conductor that is placed next to it. So this is also true. So 54, we're going to settle with D for that one. So 54 is D, so that's good work. 55 is where we are next. So 55 says that a neutral atom of argon contains 18 protons and 20 neutrons. Which of the following statements concerning the atom is/are true? Its mass, which is the nuclear number, is 38. It has 20 electrons in orbit about the nucleus. Or 3, it is an isotope of the nuclide which has a mass or nuclear number of 40 and an atomic number of 18. So 55, what we say for this one? All right, so we're selecting D. Okay, so person selecting D. We're also getting option C. Right. All right, so let's discuss this one. So it says it contains 18 protons and 20 neutrons. Right. Now, the mass number, which is the nuclear number, which is a measure of the number of protons and neutrons. Since we have 20 neutrons and 18 protons, the mass number will indeed be 38. Number 2 says that it has 20 electrons in orbit about the nucleus. Now, we can remember, since we're talking about a neutral atom, once it is neutral, whatever number of protons it has, it will have the same number of electrons. So we have 18 protons. So we should have, in fact, have 18 electrons. So this is not true. 3 says that it is an isotope of the nuclide, which has a mass number of 40 and an atomic number of 18. So an isotope will have the same atomic number but different mass number. So this is also true. So 1 and 3 is true. So we're going to go with C only. All right, so for the persons who are inquiring about the hair, um, it was sent to me, so I didn't get the hair for the paper. So I'm not certain what year it is. All right, next one now is 56, which we're onto. 56 says that a process which cannot be used to distinguish among the various types of nuclear radiation is. So let's see if we can lock in an answer for 56. No, I don't have the January paper. Don't think I do. Don't have the paper one. Last time I checked my files. But if anyone on the live right now has it and can share a copy, and we can just go through that one next. So 56, what are we saying for 56? Okay, I'm getting answers coming in for B. Okay. Also C. Yes, I want us to do another paper after this. So persons were asking about the 2025 paper, so if anyone has a copy, the January 2025 paper. Okay, yes, you can send it. All right, so 56, getting persons saying B, C. All right, so a process which cannot be used to distinguish among the various type of nuclear radiation. Magnetic deflection, right? So we know alpha, beta, and gamma, they are deflected. Um, well, alpha and beta are deflected by a magnetic field. So we can use that as a means of to distinguish between the different types of nuclear radiation. B says the range measurement. Now, we know that alpha has the shortest range, gamma has the longest range, so we can use that to distinguish them. C says electric deflection. So the alpha particles are deflected to the negative plate, beta particles are deflected towards the positive plate, so we can use that to distinguish them. So the only one is the radioactive decay, right? Because while a substance is undergoing radioactive decay, we cannot tell if it's alpha, beta, or gamma. We just know that it is giving off radiation, right? What we can do to detect it is the either the range, magnetic deflection, or the electric field deflection. So that's 56. 57 now says a magnetic field can be used to deflect a path of. So this one should be a giveaway for us. So 57, what are we going to go with? All right, let's lock in some answers for 57. All right, so we're gonna, as we finish this one, we're gonna go through 2025. Just got a copy of it. Right. So 57 cannot be used to deflect. Sorry, which a magnetic field can be used to deflect a path of? Okay. All right. So again, whichever has a charge, so beta are negatively charged. So yes, indeed, we can use that to deflect the beta rays. So we're gonna go with A for that one because it can be used. That's what they're asking for. 50. Where are we now? 58. All right. So 58 says that. Let's go forward. So 58 says that item 58 refers to the following options, each of which may be used more than once or not at all, to answer the questions below. So it says, which of the above best represents a uniform magnetic field? So which of these shows a uniform magnetic field? That's what we want to know for this one. Right, so we're getting some answers in. So let me see if I can. Right, so while we're locking in those answers, I'm going to see if I can load up the 2025 paper. All right, so the answers are coming in. All right, so let's see where we are. these. So a uniform magnetic field is represented by parallel lines. So we're getting a unanimous choice of A, right? So we're gonna go with A for that, which is indeed correct. All right. So that's what was happened a while ago. Yeah, I do. Okay. All right. So that's that. All right. So 59 now. Let's move to that. All right. So 59. All right. Give me a second. 59. 59 says, which of the following statements may be used to define the term half-life? It is half the time required by a nucleus to decay. It is the time for half of the nuclei of a sample to decay, or it is the time for the activity of any random process to fall to one half of its original value. So let's select our answer for this. So we're down to the last two questions. Let me see if I can just load up the next paper straight away. All right, so we're getting some responses. All right, so let's see what we're getting. So what persons are saying. So we're getting C, we're getting D. Also, yes, okay. So half-life is the time, is half the time required by a nucleus to decay, right? Half the time required by a nucleus to decay. No, that's not, this is not so. It is a time for half of the nuclei of a sample to decay, right? Yes, this is true. It is a time for the activity of any random process to fall to one half of its original value. This is also true. So 2 and 3 will be true. So that's C, right? So that's C. Number 60 now, last question. Which of the following scientists discovered the relationship E is equal to mc squared? I think we should all know this one. Right, number 60. Right, Einstein it is. Yes, good. So that's Einstein. All right, so that's that. So good work, that one. We're gonna go through the 2025 paper. So I have it loaded up here. Not sure if you're able to see on screen. Okay, all right. So we have the 2025 paper. Let me just refresh this thing. All right, let me just reset this. All right, but the quality is not good. All right, let me zoom in. But these have the answers on it. I'm seeing answers on these. Right, so answers are already on this. So we don't need to go through this. Right? Answers are on this. All right, so this was a 2025 paper. Seeing some answers on them. Right? Don't know if it makes sense for us to go through them. Right? Anyways, let's go through this one. Where do we this again. All right, hold on. I think I would have done something incorrect with this. Here. All right, so let's see if we have everything back up. Do we? Right. All right, so we're going to go through these questions here. So question one, an object is removed from the ground and placed on a shelf. Which of its properties is expected to increase? All right, so potential energy, that's what we're saying. Yes, this is true. So we go with B for that one. All right, number two now, let's go quickly. Number two says that the time period of a simple pendulum oscillating with a small amplitude depends on the. All right, so for number two, the period depends on the, right, so answer is coming in. So the length, yes, that's C. So question three now says that when two bodies collide, momentum is conserved. This means that the. So for this one now, D, so we're going for D, all right? Total momentum of the bodies before impact is equal to the total momentum after impact. Yes, that's true. So that's question three. Question four now. A diving ball is to be used at great depths, and so its walls are made thick. The main reason for this is that, for question four, the main reason, what could be the main reason for this one? All right, so we're getting between A and B. So A says that the water pressure increases with depth, right? So yes, the pressure increases with depth, so we're going to go with A. Also saw where persons were selecting D. Now the density of the water is going to remain the same because the density is the same throughout the water, so density does not change um, at all. So our correct answer then now would have to be A. So number five now says that item 5 refers to the following diagram, which shows a velocity time graph for a moving object. Which of the following statements about the object are true? This is question 5. What we're saying for question 5? All right, so we're getting responses for C, 2 and 3 only. All right, so one says it returns to its starting point. So we have what? Velocity against time, right? So nowhere on this graph it indicates that it returns to its original point. So this one is not true. So we can eliminate that. So if we eliminate one, means then that A is eliminated, B is eliminated, and D is eliminated. So we're left with C. Number 6 now. Right, number 6 now says, which of the following will be constant if a constant net force is applied to a body? All right, so let's give some response for this. Right, so we're getting some responses coming in. Right, so we're getting D for this one. Some person is going with D. So if there's a constant net force, right, a constant net force will cause a constant acceleration, right? So since F is equal to ma, is F, if F is constant, then the acceleration is going to be constant. So we're going to go with B for number 6, right? So that's B. Number 7 now says, an object of mass m is attached to a spring balance and its weight W recorded. What will be the result if the object is taken to the moon, where the gravitational field strength is less, and weighed? So for number 7, what are we going with for number 7? So we're getting some responses for A. So the mass will be equal to m, and the weight will be less than W. Yes, that's true. Since the gravitational field strength on the moon is less, its weight is going to be less. So we're going to go with A for that one, for number 7. So that's A for number 7. Number 8 now, as we go quickly. Item 8 refers to the following diagram, which shows a non-uniform bar pivoted at P. W indicates the weight of the bar and forces F1 and F2 are applied at the positions shown. The sum of the clockwise moments about P equals, so we want to know the sum of the clockwise moments, right, for A, well, for 8 I should say. Right, so the answers are coming in, right. Some person saying D. So let's discuss it. So we're looking for the sum of the clockwise moments, right, about P. So this is our pivot, P right here. So we're taking moments about P. So we have F2 right here acting downward from the pivot. So we're going to get a clockwise moment here. F1 is acting upward from the pivot. So we're going to get a clockwise moment right here. The weight is acting down from the pivot right here. So we're going to get this one being anti-clockwise. Now it says we need to find the sum of the clockwise moments. So the clockwise moments are due to F1 acting at a distance D1 from the pivot, right? And F2 acting at a distance of D2 from the pivot. So we're going to have F1 times D1 plus F2 times D2. So we have to go with D for question 8. Right, so good work on that. Question 9 now says, a boy measured the height of a laboratory table. Which of the following measurements is most likely the correct one? So for question 9, what are we saying for this one? So getting some answers for C, right? Right, so we're getting C. All right, so what we see then, the most suitable answer in this case is in fact C, approximately 1 meter, right? Everything else is ridiculous. 8.9, that's basically a 2-story building. So the best answer is C, so 9 is quickly C, so let's lock that in. Next question is question 10. Item 10 refers to the following diagram of a vernier caliper. Which of the following readings is shown on the scale above? So let's read this vernier caliper for question 10 and lock our answers in. Alright, so we're getting some answers coming in. Getting answers for B. Alright, so let's see this now. So when reading the vernier caliper, we look for the last reading, which is 12. Before we say the vernier scale, so we have 12, 12.1, 12.2. So we know that the whole number portion is going to be, well, not the whole number portion. The first decimal value will be 0.2. So we're going to have 12.2. Now we'll look for the mark that lines up perfectly with a mark on the main scale. So this one lines up perfectly, which is the sixth one because it follows 5. So we're going to have 12.26. So the answer then is indeed B for number 10. So that's 10, number 11 now. Let's find that. Which of the following features must be present in a stable, well-designed racing car? So a stable, well-designed racing car must have so answers are coming in. Persons are indicating A, right? Yes. So if it's stable, must have a low center of gravity. So A is true. That's 11. Number 12 now. The unit for momentum is, so unit for momentum. We're getting some answers. Okay. All right, so let's recall that momentum is the mass times the velocity. Now mass is measured in kilogram and velocity is meter per second. So we're going to get kilogram meter per second, which would be B. So 12 is B. All right, so good work. Question 13 now says that in an experiment to locate the center of gravity of a sheet of cardboard, a plumb line, which is a string with a small mass at the end, is used. The plumb line is used to so what we're saying for question 13. So we're getting some answers for 13. We're getting C thus far. C says, show which points are vertically below the pivot. Yes, so C is correct, because whichever point is directly below the pivot, if the what's that now? What do they call it again? The sheet of cardboard is suspended from that point, is going to remain in equilibrium. So 13 is indeed C. Number 14 now. 14 says a bubble of gas rises to the surface of a soft drink. This is because so let's see number 14 now. What are we going to say for number 14? Number 14. All right, so we're getting B. So for the persons who are querying about the years, I could check the person who sent the documents for me to find out the years. But as you can see, the year was not listed on it, so I'm not sure what year it is. All right, so where are we now? Number 14. We're going with B. Upthrust on the bubble is greater than the weight of the bubble. So the bubble of gas rises, right? So if it rises, the upthrust must be greater than the weight. So B is definitely true. So we got B for that. So number 15 now says, given that force is equal to mass times acceleration, the unit of force could be written as, which of these could we use for the unit of force? Right, so D, person is going with D. Okay. Right, so kilogram meter per second squared. Right, so mass is in kilogram, acceleration meters per second squared. So yes, D is true. Which of the following pairs consist of fundamental quantities? I think we would have seen this question in the first paper. Right, so what are we going to go with for number 16? Right, so we're going for D. Right, so 16 is D. Yes, that's correct. Again, we saw that in the earlier paper. All right, so number 17 says that as the temperature of a liquid rises, its density increases. This question also looks familiar, right? I think we saw this before. So number 17, what are we going with for number 17? All right, so number 17, we're getting responses for C as well as D. So it says that as the temperature of the liquid rises, so the temperature of the liquid rises, the molecules are going to gain kinetic energy. So they're going to be able to move about faster. So A says density increases, that's not so. Force between molecules increases. and that's not so. The kinetic energy of its molecules increases. This is true, so we're going to go with C for that one. Number 18 now. So number that was 8. The C, number 18 now, says a metal of mass M requires energy E to raise its temperature from T1 to T2. The specific heat capacity of the metal will be given by. So number 18, what are we saying for 18? Right, so getting some answers. Right, the person saying C. Right, the person saying C over here as well. So we go with C, right? And again, energy is equal to mc delta T. Delta T is just T2 minus T1. So E is going to be equal to mc times T2 minus T1. Now, this should find the specific heat capacity, so that's C. So C is going to be equal to the energy divided by M delta T, which is T2 minus T1. So that corresponds to C. All right, so that's good. Next one now is number 19. So let's go forward with this. Number 19 is where we are. It says, which of the following ranges of temperature is most suitable for a clinical thermometer? So which of these would we use for our clinical thermometer? Right, so okay, getting some responses for D. Right, D. Right, 35 to 44 degrees Celsius. Yes, that is true. Right. So this one is D. 1 second. All right, so, and again, for clinical thermometer purpose, we measure body temperature, right? When you're alive, the temperature is within this range. So it's reasonable to keep the range limited, so that we can actually have a more precise value when we actually measure temperature of the human body. That was 19. Number 20. Yes, exactly. Human is 0 degrees. Somebody who is very cold. All right, so that's number 20. We're on to number 20 now, I should say. And it says that this question, right? So we have this. We know what's the premise of this. It says ice wrapped in gauze at the bottom. We have boiling water at the top, yet the ice is not melting. So the main reason for that is, what's the main reason for the ice not melting? Okay. The answers are coming in. Some person saying C, some person saying B, so I'm going with D. Right. Right, so for number 20, so our answer in this case, so since we have the water boiling at the top, right, yet the ice is not melting, the reason for that is because the water is not able to conduct water effectively down to the ice. So the ice remains unmelted. So the reason for that is because, again, water is a poor conductor of heat. So we have to go with B for that one. Number 21 now. 21 says that the specific latent heat of fusion of water is 340 kilojoules per kilogram. This means that when 10 kilograms of water freezes, so what we're saying for 21, Right, so 21 answers coming in. All right. All right, so let's discuss this one. So we're talking about the zoom in some more. Talking about the ice freezing. So in order for the ice to freeze, it must give off heat, right? It has to give off heat. So heat must be given out. So it's either A or C. Now, in this case, now we can consider that the heat energy is going to be equal to ML, what's the thing called? ML fusion to LF, right? So this is going to become mass is 10 kilogram multiplied by 340, right? So we're going to get 3400. So our best response is 300 or 3400, which corresponds to C. Right, so we'll go with C for that one. Right, so that's 21. Number 22 now says an electric kettle full of water is plugged into the mains. The major process by which heat travels through the water is. Right, so we're getting some responses. So 22, we're getting B. Some person going with C. Right. So it says that process in which, sorry about that. It says the process by which heat travels through the water. So in this case now, since we're talking about heat traveling through a fluid, that has to be convection. So we're going to go with B for that for 22. So 22 is B. 23 now. Which of the following material is both a good absorber and a good emitter of thermal energy? So we want to identify which of these is a good absorber and a good emitter of thermal energy. Right, so good absorber. Yes. All right, so yes, I had some technical issues a while ago with the microphone. All right, so which of these is a good emitter and a good absorber? All right, so person going with D, a flat metal plate painted black. Yes, would be a good absorber. So that's D for that one. 24, when, let's go again. So 24 is here. 24 says that when heating a substance, a point is reached where no further change in temperature is observed. The most likely reason for this is that the so we're going to go with for this one, 24. All right, so we're getting responses for A, getting responses for D. Right. So in this case now, it says that even though we're supplying heat energy, there is no change in temperature. And the reason for that is because that heat energy is being used to change the state of the substance. So our answer in this case now would be A, change in state. So 24 is A. All right, so we're getting there, 25 now. To check the upper fixed point on a thermometer on the Celsius scale, the thermometer is placed in. So how can we determine the upper fixed point? So person's going with C. Okay. All right, so persons are going with C for this one. So for the upper fixed point, that's the temperature at which pure water boils. Right. So we can determine upper fixed point by simply placing the thermometer in steam above boiling water at atmospheric pressure. So that's going to be notice, for C it says steam above boiling water, right? So the steam, right, will have a temperature higher than the upper fixed point. So in fact, we won't actually place it in boiling water, right, at atmospheric pressure, right? So we're gonna go with B for that one for question 25, right? So 25 is in fact B because C says it is steam above boiling water, right? So we'll go with B for 25. Now 26 is where we go next. Responsible for arriving at the conclusion that measured amounts of electrical and mechanical energy can be converted to proportionate amounts of heat energy. So which scientist was responsible for this? So some answers coming in. So yes, this person who was responsible for that was Joule. That is why we give the unit of energy, the Joule, after that individual, James Joule. All right, number 27 is where we go next. Right here. Right, getting some. And we continue quickly. All right, so I want to know which of these is false. All right, so let's see which one is false. So let's see again now about evaporation. Evaporation requires heat energy and causes cooling. This is definitely true. In evaporation, the faster molecules escape the liquid. Yes, that's true. Evaporation occurs at room temperature only. That's not true. Evaporation only occurs at the surface. This is true. Evaporation occurs at any temperature. So C is false. Right, so our answer for 28 would be C. All right, so we're not hearing. Confirm the audio for me, please. All right, so we have audio. Let me know if you guys are hearing me, or I need to throw away this. Okay, perfect. All right, good, good, good. All right, so that's 28. So now we go to 29. Okay, good, thank you. So 29 now is where we go next. So 29 now says that item 29 refers to the following diagram, which shows a longitudinal wave train produced on a slinky. Which of the following distances represent the wavelength of the vibration? So for 29, we need to identify the wavelength. So what's going to be our wavelength? All right, what we're saying about this one? What's the wavelength? B. Okay. So we're getting suggestions for B. All right. So for this longitudinal wave, the wavelength will be measured between successive compressions or successive rarefactions. So regions of compression are where the spring is close together, and regions of rarefactions are where the spring is further apart, or the coils of the spring are further apart. So if you look at C, we have a compression right here, and the next compression is at E. So from C to E would represent one wavelength. So we go with B for that. So 29 is B. 30 now is where we go next. Which of the following statements is true for a diverging lens? All right, so which of these is true for a diverging lens? All right, so for diverging lens, we're getting A. It is thinner at the center than at the edge. So this is what a diverging lens is. So it's indeed thinner at the center than at the edge. So we definitely have to go with A for number 30. So 30 is A. 31 is where we go next. This is 31. So 31 says item 31 refers to the following diagram, which shows an object in front of a plane mirror. Which of the following options best represents the image produced by the plane mirror? So we want to know which of these is the image formed in the plane mirror. All right, so 31. What are we saying for 31? All right, so we're getting some persons going with A, some going with B. All right, so let's see what we have here. So we have the object, the arrow, right? It is upright. Now, what we need to remember is that the image in a plane mirror is always upright, right? Image in a plane mirror is going to be upright. So our answer could either be B or D, because the image must be upright. So if the object is upright, the image is also going to be upright. Or in other words, if the arrow is pointing up, image must also point up for the plane mirror. Now, another property of our image in a plane mirror is that it is laterally inverted. So what's on the left appears on the right, and what's on the right appears on the left. So then, what it means now is that since the head of the arrow is on the right hand side, in the mirror, it's going to be on the left hand side. So which allows us to settle with B for our answer for this question. So we're going to go with B for that one, for number 31. So good work again for that. Let's go now. So 32 is where we reach. So 32 says, which of the following statements about sound is not correct? So which is not correct about sound. All right, so what are we saying about this now? All right, so we're getting C. Sound is transmitted as transverse. So it says not correct. So this is indeed not correct, right? Because sound is longitudinal. So 32 is C. All right, so 33 now, let's set up that. 33 is where we go next. So a ray of white light enters a transparent glass prism. In which of the following diagrams is the dispersion of light correctly illustrated? So we want to know which of these display dispersion correctly. All right, so we're getting some answers. We're getting A, getting B. All right. So we have to recognize that when we have dispersion taking place with a glass prism, we're going to have our single beam of ray undergoing refraction at both interface. So the interface between the air and the glass, we're going to have refraction taking place. And the interface between the glass and air, we're going to also have refraction taking place. So we're going to have the light refracting both times, 2 times. Now, each time the light refracts, we're going to see that the different colors are going to refract at different angles based on their frequencies. Right? So based on their frequency, they're going to, or based on their wavelength, more precisely, based on their wavelength, they're going to refract at different angles. Now, what we're going to see now is that we're going to have the color raw GBIV, right? So the answer could have been A or C. So we're going to have in the order red, orange, yellow, green, blue, indigo, and violet. So our answer then now has to be option A for that one. So 33 is A. 34 now is where we go next. So 34 says, which of the following properties is true of both light waves and sound waves? So which is true? So 34, that's where we are. What are we saying for this one? What's our B for 34? Which of the following properties is true of both light waves and sound waves? All right. So D says that they are, they undergo refraction. This is true. For the here, as I said earlier, I would have to check with the person who sent the paper because I didn't get there here, just working through. So 34, we say was D. So 35 now. Item 35 refers to the following diagram in which two coherent light sources produce an interference pattern as seen on a screen of bright and dark fringes. So we have this right here. So 35, that's where we are, 35, yes. The reason for the formation of the bright fringes is that, so I want to know why we have the bright fringes being formed. Let's zoom that in a little more. So 35, what are we saying for 35? C. That's one option coming in. C coming in here as well. All right, so persons are going in with C. All right, so we have the bright fringes. So the reason we have bright fringes is because we have constructive interference taking place, right? And for constructive interference to take place, the waves must be in phase. And when the waves are in phase, the crests line up and the trough line up. So two waves in phase, we're going to have the crest of one line up with the trough of the other. So let's say we have a wave like this. And if we have another one, let's say a little bit below, if we have them like so, where the crest of one wave lines up with the crest of the other one, and the trough of this one lines up with the trough, they are going to be in phase, and we're going to have constructive interference. So C says that all the crests and troughs are in phase along these points, and that is definitely true. So 35, we'll go with C. So 35, 36 now. 36 says a ray of light leaves the air and enters glass of refractive index 1.5. If the angle of incidence is 37 degrees, what is the sign of the angle of refraction? All right, so let's lock in some answers for 36. So 36, we're going with D or A. So we're going with both D and A. All right, let's see this. So it says that we have a light going from air and enters glass. So the refractive index N is sine I over sine R. Now, in this case, they want us to find the sine of the angle of, what is the sine of the angle of refraction? So we want to find sine R. So we can transpose, we're going to get sine R is equal to sine I over N. Now, since our angle of incidence is 37, we're going to have sine of 37. So this is going to be sine 37 over 1.5, which resembles D. So 36, we go with D for that one. 37 now says, so that was 36, so 37 is next. 37 now says, which of the following objects can detect X-rays? So from the list, which of these can we use to detect X-rays? All right, so we're getting some responses. Some persons saying D, some persons going with B. All right, so let's see. So X-rays can be detected by photographic films, right? Which is what they use in the hospitals to do X-ray exams, right? So 37, X-ray can be detected by photographic films. So we'll go with B for that one. Now we're on to 38, which says a note from a drum is louder when it is struck harder because the sound waves produced have a greater. So 38, what do we say? Right, so right, it's louder because there's a greater amplitude, yes. So C is correct. Amplitude. 39 is where we go next. So 39 says, which of the following phenomena are exhibited by sound waves? So 39, what do we say for 39? We have, from the list, we have refraction, diffraction, and interference. So So we have some answers coming in. Person's going with D, person's going with C. Right, so let's see. So we have refraction, as I said, diffraction and interference. Now, we should recognize that all waves are able to refract, diffract, and interfere. Now, sound wave just happens to be a wave, so obviously it will also be able to undergo these three phenomena. So our response would be D. So 39 is D. Next, we're at number 40. Which of the following diagrams represents the electric field existing between two oppositely charged point charges? So which of these will be between two oppositely charged point charges? All right, so we're getting some answers coming in. Getting an A. All right, some persons suggesting D as well. So since we have opposite point charges, they're going to attract each other. Now, one thing we need to recognize is that for the positive point charge, the field lines go outward. Negative point charge, the field lines go inward. So once they are close enough, what's going to happen is that the field lines are going to interact, and we're going to get the pattern consistent with option A, right? For D, this would be the case if both of these were positively charged, right? And they're both going outward, they would actually form this pattern. But since they're opposite, then this is not going to happen. So that's 40 right there. So 41 now. Let's go forward. So 41 says, which of the following symbols represents the AND gate? So the AND gate, what's going to be our AND gate? All right, so we're getting some answers. All right. Getting C, getting B. All right. So the AND gate, one way I like to remember the AND gate is just by the letter D right here. So the symbol looks like a D. So the one that is similar to this is option B. So we'll go with B for that one. So 41 is B. 42 now, as we get closer, says which of the following relationships between electrical quantities is correct? So 42, which of these would be correct? All right, so we're on to 42. All right, so we're getting some answers coming in. All right, so the relationship which is correct from the list right here is C, which says that Q is equal to I times T. So we're going to go with C for 42. All right, so the answer is C. All right, so next one now is 43. Which device allows one circuit to switch another circuit on or off without any direct contact between them? So we're at 43 now. What can we say about 43? All right, so we're getting A. Right, getting A. right? So a magnetic relay, right, allows us to control a circuit without having to be electrically connected to it. So 43 is A. 44 says a glass rod is rubbed with a piece of silk and is positively charged. The glass rod became charged by all right, so let's see what we say for 44. All right, so some answers are coming in. All right, so we're getting B, we're getting A, we're getting D. All right. All right, so again, let's just consider what's happening. So for charging to take place, we're always interested in the electron. So let's cross out anything with protons because the protons will never move when we charge an object. Now, since it is becoming positively charged, right, it must be losing negative charges. So it's going to be losing electrons to become positively charged. So our answer then now for 44 is going to be B. All right, so that's B. So 45 is where we go next. So when an excessive current passes through a fuse, which of the following is a sequence of events? So let's take on 45 now. All right, so what we say for this one, 45, we'll say B. All right, saying B. So B says the wire gets hot, wire melts, and the current is cut off. Yes, that is true. So 45, we'll go with B for that one. Yes, straight common sense. Right? That's what physics is all about. So that's 45. 46 now. It says which of the following current time graphs best represents a DC current? So let's see which of these for number 46 will be a DC current. Which of these is DC? Right? So person is going with A, some person is going with B, it seems. Right? So we can recall that DC current flows in one direction. So it doesn't flow positive and negative, right? It's either going to be straight positive or straight negative. So the only one that shows that is option A, right? So 46 would be A, right? So 46 is A. 47 now, zoom that in. So 47 says that we have the diagram below. Now we want to determine what would be the appropriate labels for the device W and what would the input at X be. So what are we going to say for 47? Right, so we're getting B, getting C. Right, so we're getting B and we're getting C. All right, so first thing first, when you look at this device, right, it's a transformer. I mean, we can tell that it is a transformer because we have all these options being transformers, right? Now, a transformer only works with alternating current. So it means then that our answer could be A, or it could be, I'm going to put a tick, it could be A, with the asterisk, it could be A, or it could be C. Now, what we can use to determine if it's step down or step up is look at the number of turns. So if we have more turns on the secondary, then it's going to be a step up, right? Step up. So we're going to go then now with C, which says that it's a step up transformer. So that's C. For 47. So 48 now. See you next. So 48 says that we have this current time graph, and they say what is the period of the current. So for 48, we want to know the period. So what's the period of this current time graph? All right, so person is going for B, right? So the period is the time for one complete oscillation, which is this right here, which takes place in 4 seconds. So B is indeed correct. So that's 48. So now 49. An ideal transformer has a primary to secondary turns ratio of 1 to 3. An alternating potential difference of 200 volts is applied to the primary coil and a resistance of 200 ohms attached to the secondary coil. What is the current in the secondary circuit? So let's see what we can do for number 49. All right, so 49. So we're going with D, seems, right? So since the turns ratio is 1 to 3, then the voltage or the potential difference on the primary, right, is going to be multiplied by a factor of 3. So on the secondary, we're going to have a voltage of 3 times 200, which is going to be 600 volts. And since we're trying to find the current, we know that resistance is V over I. So V is 600. Sorry, what we're trying to find? We're trying to find current, my bad. So not R we're trying to find, we're trying to find the current. What's going on? Okay. So I is equal to V over R. So V we said was going to be 200 times 3, so that's 600. And R is 200. So obviously that's going to give us 3 amperes. So 49 is definitely D, right? So 49 is D, right? So that's that. Number 50 now. Says which of the following combinations of ammeter characteristics is correct? So let's see what's 50. So we have just a few more questions to go. Right, so we're going with B. Some person going with B. So what we should always remember is that for an ammeter, it's always connected in series. So we could have B or C. Now, since it is connected in series, we want to have the resistance of the ammeter being very low. So 50 is going to go, we're going to go with B for number 50. All right, so 51 now says 51 refers to the following diagram, which shows two resistors R1 of 6 ohm and R2 of 4 ohm in parallel. What is the current through R1 if the current through R2 is, that's what, 1.8 amperes? So we want to know what's the current through R1 given that the current through R2 is 1.8 amperes. So what we're going with for 51. Right, so we're saying D for 51. Right, some person is going with A. Right. So, okay, some person going A, some person is going D. So for this question, we can look at it intuitively. So we have these two resistors in parallel, right? Now, as we said before, current always take the path of least resistance. So in this case now, with R2 being 4 ohm and R1 being 6 ohm, the current will tend to flow through R2 more. So we're going to have a greater amount of current flowing through R2 than R1. So since the current through R2 is 1.8 amperes, then the current through R1 must be less than 1.8. So the only option where the current is less is A. So we have to go with A for 51. 52 now is this one, which says that the best material for the core of an electromagnet is 52A, right? Person is going with A. So for the electromagnet, we have to use soft iron. So our best answer in this case is going to be A. All right, so we're now next to 53. Kind of going a little bit fast because I want to get off here before in the next 10 minutes. So just bear with me, please. So 53 says that this is what we have. We have a 12-volt source. We have a lamp in which the potential difference across is 12 volts. And we have these resistors A, B, C. Given that the potential difference across the lamp in the circuit is 4 volts, what is the potential difference across resistor A? So since these resistors are in parallel, the potential difference across them is going to be the same. Now, in this case, now we have this lamp being connected in series with this parallel network right here. So since we have 4 volts across this, then the remaining voltage of the source is going to be dropped across this branch right here. So to find the potential across this, we can simply subtract 4 from 12, right? And that's going to be the voltage across this right here. So our answer then now for 53 would be B, 12 minus 4 volts, right? So we subtract 4 from 12, we're going to get 8. So we're going to have 8 volts across this right here. So the answer in this case is going to be B for 53. So 54 now says, which of the following describes two properties of an alpha particle? So what's two properties of the alpha particles? Right, so saying D, positive charge but not very penetrating. Yes, that is true, right? Alpha particles are highly ionizing, so they cannot travel too far in matter, so they're not very penetrating, so D is correct. So next one now is 55, so we have 5 questions to go. Isotopes of an element differ from each other in that they have a different All right, so for 55, what are we saying? B, some saying B, some saying C. All right, so isotopes, they have the same atomic number. So if they have same atomic number, they're going to have same number of protons, right? So they differ by the number of neutrons. So 55 would be C. All right, so 55 is C. All right, so C for 55. 56 now, get in there. Which of the following graphs shows how the activity of a radioactive source varies with time? So we have our graphs right here. So what are we saying for 56? Right? Definitely. So 56 is D, right? So the activity decreases with time in a um, non-linear manner, as what we see right here for D. So that's 56. Next one is 57. And we see this question sometime before. Which of the following scientists formulated the equation E is equal to mc squared? That's our good friend, Albert, right? So that's Einstein. So 57 is D. Now 58, so two more to go, well, three. Which of the following statements about radioactive decay are correct? So which of these statements would be correct? Right, so A, it is dependent on conditions external to the nucleus. It is a random process. So let's see now. So it says radioactivity depends on the conditions external to the nucleus. This is not so, right? It is a random process, yes, for true. It is due to changes in the nuclei of atoms, and that is also true. So our answer then would be 2 and 3, which is C. So our last two questions, let's see if we can get them. Which of the following statements about radioisotopes is true? So which of these is true about radioisotopes? All right. So we're going with C again. So they are sometimes used in medicine. Yes, this is true. So 59 is C. And then last question now. An isotope of uranium 234 changes to thorium 230. This is an example of, so we see that the mass number reduced by a factor of 4, or reduced by 4, I should say, and the atomic number reduces by 2. So that is in line with what we refer to as an alpha decay. So 60 would be A. All right, and this is our um, paper. Right, this is our paper. For I got a response for the from the person. So this paper, by the way, this paper was last year's paper, 2024, And the one before that we did, this was from back in the year 2002. So this one here, this one 2002, and this one is 2024, right? So those are the questions. So hopefully we're able to gain something from this. Hopefully this was helpful to you as you prepare for your exam this Friday. If persons wish to reach out to gain access to more practice questions like these, I have some practice questions in an interactive format. You can send me a direct message, and I will provide you with those. I'll just post my contact that you can reach me by, and I can share with you some more of these questions that you can practice. And as you practice with them, it will provide you with instant response, so you'll know whether your answer is correct or not. So you can reach out to me, send me a direct message, WhatsApp, and I will just share that with you. And again, all the best on Friday. All right. And thank you for being a part of the session.